Welcome to my first presentation on the Linux kernel. This is the first one. I would like to talk about how to get started with the Linux kernel. My name is Jules Iringe. I'm a kernel hobbyist. Also, I'm a graduate of LFX mentorship program. I can describe myself as an open source software contributor. I am more interested in contributing in the kernel Linux kernel subsystem and the drivers. I have blog, and you can find me at my blog julesiringe.blog, and also you can connect with me on my LinkedIn, and we can follow each other on Twitter. As hobby, I like jogging. I enjoy chess game, and also you can find me at some social event, especially IT events. So let's start. The agenda of the day, we have an introduction, and we'll talk about how to set up your tools for those who want to be those kernel enthusiasts. And also we'll explore the kernel tree and talk about some tools to find faults in the kernel, and also attempt to make a driver change and show how to submit our first patches. Introduction. This is a testing for a Linux kernel enthusiast meetup. So what we had in mind is like the meetup is for like-minded individual who are passionate about the Linux kernel. In this group we would like to focus on sharing knowledge, networking, and collaborating on some kernel-based projects. First of all, before endeavoring, what are the requirements that are needed to start a Linux kernel journey? First of all, we need an operating system, which is, of course, Linux, and we will need to install some packages like GCC, make, as the CTAG, and BCC. As you can see, those are the commands we can make on different distribution in the Linux kernel. And also we'll need a Vim, or for those who are like Emac, or for those who prefer VS Code or some other code editor. For the email client, I'll be using Mutes, but you can also use Alpine, and for Thunderbird or any email client to send your patches. First of all, we would like to set our email clients. So for us, we'll be using Mute, and as you can see, if you just copy paste this command to install Mute, and make a directory, a body, headers and body, and create a file for certificates. Then you go to your Gmail account. In the setting of the Gmail account, you click on your photo, then you get to setting. Then after getting setting, you get to app password, generate an app password by selecting the mail. Then in application, you type Mute, then click generate, and you have an app password. Then I would like you to create a Mute RC file where you just copy paste this code, and you replace this script, and you replace the email by your Gmail account if you have one, And here the set email pass, you replace this one by your generated app password from your Google Chrome Gmail. And you replace everywhere your username, you put your username for your Gmail account. And yeah, that's it. Your Gmail account here, username, Gmail account. And you are good to go with Mutarxi. Well, we'll need also to configure Git, which it's an application which is used by software developer, and it's a version control which was started by Linus Torvald, and these are the commands to put your username in the git config file. If you launch this command, you replace this John Doe by your name, and you replace this Gmail account by email address that you would like to submit your patches with. And to explore the kernel, we need first to clone the kernel from the repository. Then we change the directory to in the Linux directory. Then we can find, if you put an ls, we'll find all these folder which are in the Linux kernel. Then for us, we'll be most interested in the kernel, or in the kernel and the drivers. We'll be working mostly in the kernel and the drivers. And after the git clone is complete, you can click on git branch to view the branch which are there. You will most likely find master's branch, and then you will create your own your first branch, your branch for your patches. So by this running this command git check out the my patches, which take you directly into your branch. If you click git branch, you'll find your branch pointed, your code pointed is your new branch, my patches. So after that, you'll need maybe, if you spend a lot of time without using your kernel, like 2 days or 1 day, you need to update your kernel. So by updating, you just click write this command, launch this command called git fetch origin. This git fetch origin will update your kernel, and then check your patches. You can check your patches. You can say git log origin to see if the changes you made, to check the changes you made, and then if they are already on top of they are updated. If they are not updated, you can launch this command git rebase origin to put your patches on top of the updated kernel, because you can commit your patch into an old kernel, and after you have to git fetch your origin, update your kernel, you update the masters, you have to rebase your patch on top of a new kernel. So as you can submit the kernel. So how do we build the kernel? First of all, we need this .config file. This .config file, we create the .config file. We can create it by doing a touch.config file. Then after that, if you're on a Fedora Linux, you copy the boot config into the configuration into your .config, or you can make if you're on some other distro where you have this proc config GZ, like Arch Linux and some other distro, you can just type zcards. You redirect it into your into the .config. After that, you can now compile your kernel. So you say make -j nproc. Nproc is for number of processor. You can ignore this -j, but it will still work, but it will compile a bit slower. So what are the tools to find faults or errors or warning in the kernel? There are so many tools. Actually, you cannot find there are so many in the legs, and some are still coming up. But the major one, which the kernel engineer, kernel developer used the most, is this tool called Sparse, which was started by Linus, and we have also Smatch, which use Sparse in some ways. We have also coccinelles. These are the static tools. These static tools which can be used, but the problem with static tools, sometimes they do give false positive error, false positive faults. By false positive, I mean it can show an error, but it's not really an error. It's just it's not an error. It's correct. The code is correct, but it's just throw some error. But by my experience with Sparse, I find that Sparse does not give a lot of false positives, just few of them. And if you submit a patch which correct an error with Sparse, it will definitely get accepted in the Linux kernel, unless it's really one of the rare false positive. For check patch, development normally they use it for checking whether the patch is correct, but you can still find some very few errors with check patch. Although check patch can also has a lot of false positive. And the other tools which are used is the dynamic analysis tools. There's tools that use dynamic analysis program. There are so many of them. So here I just listed two. There's this fuzzing tool called Syscola, another system called fuzzing tool called Trinity. Syscola is very popular because it has found a lot of bugs in the Linux kernel. But for the dynamic analysis, this dynamic analysis, they don't find false positives. They tend to find error which are actually error. We have some other type of debugging tools like regression testing. Also, you can use tracing to find bugs. So some people can use eBPF, or you can use some other technique, F-trace. There are a lot of them that when you start your journey with the kernel, you'll find them. There's so many. So what about Sparse? Sparse is very easy to install. It's just a bunch of commands here. Then to compile, to run Sparse, it's very simple. Once you are in the Linux directory which you have downloaded, you just make C is equal to 2, capital C is equal to 2 for the first time. Once you find an error and you correct the error, you don't want to compile all the kernel again. You just want to compile the file which has the error. So when you put make C is equal to 1, it will just compile the file which is not compiled yet. That means the file that you change also is not compiled yet. So to compile it and find if the error is fixed. You can see if the error is fixed. We have also Coccinelle, which is very interesting, but sometimes it can give false positive, and you have to check. It's not a very old tool like Sparse, but it's also interesting. I myself submitted some patches that I use Kernel to find the bugs, then I just fix them. And where we can find Smash, makes you run this command, but Smash normally use sparse to find problems in the kernel. So about this dynamic analysis tool, there's a lot of Syscola. You can find Syscola on GitHub and install it and play with it. So how do we make changes? We first check for example, if you want to make changes on a driver that is loaded in your machine, you just say ls mod, and you'll find the driver that is loaded, the name. Then you can go to your Linux directory. If the name of the driver you want to find is i915, you want to find the location where it is, the driver. So you just git grep, then /, then on the make file inside the Linux directory, then you'll find the location of this driver, whether it's a lot of place, the location, then you find it. Then after you find the location where this driver is mentioned, or the location, the real location of it, then you can go into it and you find some, this alternative, you can launch this command called find drivers name to do the driver's location you find, whether it's in staging or i95, i915 here, name to do, then you find everything that is left, not yet done. And you can take it one by one. No, for example, here I use checkpatch.pl to find some error, checkpatch, but the checkpatch normally finds a lot of false positives, so you have to be careful with it. So you can submit a patch which is not a patch, really, it's just a false positive. So, but you have to be careful whether you have to look at it, whether this is an error that need to be addressed, or this is just a false positive. You can use Google and to check, and so yes, there you can find where the error is. Then you can change the error, change it and remove it. Then after removing, we compile using make command. After make command, you compile again, use if everything works well, then you sudo make module install, and you can see after install you can reload your module name and see whether you fix the issue. Yes, now we come to our first patch. Or are you doing with time? Okay. Our first patch is first we install CodeSpell, which is a package. You can install it with a DNF or apt install CodeSpell in your Linux distro. Then you can create this. You can go to your Linux folder. Then you create this file, Linux folder where your source code is, the kernel source code is. Then you go to this Git file. It's an hidden file, so you have to put this .git, then you can find the hooks. Then you create this post commit file. You type post commits. You can use Vim. Then you just enter this these two line here, the shebang line and the exec line. Enter them. Then just save it. After you save it, you chmod it. You make it executable so that after you type a script, it will show you whether after you write a comment on your patch, it will show you whether the patch is okay, or sometimes it will show even some error you've included in the source code. Yes, that's it. Then after you change the file, you have to git diff. Then you can see whether it's really what you git diff on your commands in the terminal or something. Then it's really what you want to change, really. If it's that what you want to change, then you can add it. You can add the change from the file where you changes Then after git add, then you can git commit, you put the title, maybe it will be fix error from the warning, then it will be in the description of what your fix does, or whatever you insert in the kernel. And then after that, you format your patch. For me, I'd like to put -1 for like you format your patch. You want it to be, you want to send your patch because it will, after git format patch, it will give you a file with .patch. So you format the first, when you put git log, you see the first in the line, which will be -1 git format patch. Then -1, it will be the first in the line, or when you put you type git log, then -0 to specify the location where you want the fetch to go. For me, I put ... so as I don't want it to be in the Linux kernel source file, source directory, but I want it to be outside the Linux kernel source directory. You can also make a folder. You can say patches, my patches. Then you can put or direct this patch to this folder, my patches. Then after that, you check the maintainers. Who are the maintainers of this file? So there was a script in the Linux kernel called /script in the Linux kernel directory, and then can get maintainer.pl. It's a PAL script. So then we can, if the file you change is this one, for example, you can put the file change there. If the relative path to the file you change, and then after you press enter, you'll see a list of maintainers and list of maintainers. Then after that, all those emails there, you can type mute.h. There's a small mute, not capital, on the terminal. Then -h, capital H. Then you can put the file you created here .patch. Then you put it here. You then, after you click send, it will give you some it will give you some where to send, who to send. You just copy paste the email of this the email you find from this scripts of the maintainers, and you can send it to the maintainers. And then you just press enter. Hope everything's all right there. Yeah, this brings us to our end. I hope you enjoy the short presentation, but this is supposed to take us into our first presentation, but I'll see you next week. If anyone has a question, just type and send, and I'm happy to reply. Thank you. Okay, now it's time to stop record.